Okay, next we move on to theories of reaction kinetics. This particular theory, right, collision theory, it states that chemical reaction occur only if there are effective collision. And when do they happen? When the reactant particles collide with energy that's greater than their activation energy, and they collide with the correct orientation. Right? So the rate of reaction is directly proportional to the frequency of effective collision. Okay, so quick tip for you, collision usually involve less than 3 particles in any single step. Okay, because the probability of 3 particles colliding and reacting at the same time is very low. All right, so activation energy, what is it? It is the minimal amount of energy that the reactant particles must possess so that the reaction can happen. So it is like an energy barrier. All right, so EA is the energy level difference between the reactant and the transition state. So what is a transition state? All right, it is a species formed in the course of a reaction, and these are very unstable, cannot be isolated. All right, so they are represented at a point of maximum energy. All right, and they are different from intermediates because intermediates, which can be unstable, but they can be isolated. All right, so they are represented at the minimum point between two transition states. Okay, so we look at the energy profile diagram, right, for elementary reaction, which is one step. So if you look at the endodermic, right, so you can observe that the reactant energy level and the product energy level, actually after the reaction, right, the energy level of the product becomes higher than the reactant. Okay, note the transition state. Okay, and compare that to an exothermic reaction where energy is given out, right, through the reaction, and the energy level of the product ends up lower than the reactant. Okay, so now we look at this non-elementary reaction and exothermic one. So you realize that the peaks, right, are what we call the transition states. And this here, right, the lowest point is actually called an intermediate. All right, so the intermediate energy level is higher than the reactants. Okay, also take note of this two labels. Okay, now we're going to look at the factors affecting rate of reaction, which involve concentration, temperature, catalyst, and the other three. These other three others are not so significant. The more significant one is the first three. Okay, so let's look at concentration. When the concentration of a reactant is increased, right, what actually happens? The number of reactant particles per unit volume increases. The frequency of effective collision increases as well. And the rate of reaction is proportional. Since the rate is proportional, right, to the frequency, the rate of reaction itself increases. All right, so we can explain this using a Maxwell-Boltzmann distribution curve. It's quite a mouthful, but this is what the curve looks like. So basically, your y-axis is the number of particles with a given energy, and your x-axis is basically your energy. Okay, and focus on the graph with T1, right? So basically, the shaded area, the orange shaded area, or the red shaded area, is the area with particles with at least activation energy. All right, so these guys are the ones that are reacting. Okay, the area which is not shaded, right, they are not reacting. All right, because they do not have enough energy. Okay, so if we raise the temperature to T2, right, what happens to the graph? The graph is actually broadened and flattened. right, is broadened and flattened. And we will have more of the particles having enough energy, E greater than activation energy. All right, so it ends up we have more effective collision. And since the rate is proportional to the frequency of effective collision, the rate of reaction increases. Those of you who take bio, right, you will know that for every 10 degrees increase in temperature, the rate of reaction doubles. Okay, what happens if we have a catalyst? Okay, a catalyst reduces the EA, all right? So if we look at the Maxwell-Boltzmann, right, we only have one curve, not two, because the temperature didn't change, right? So the energy of the particles actually didn't change. What changed was actually the requirement, all right, the EA. So it shifted from uncatalyzed to catalyzed. So you see more particles have energy greater than activation energy. All right, so you can read this explanation yourself. It makes plenty of sense. It's almost the same as temperature except for this first bullet point. Okay, so if you look at the energy profile diagram, right, you have the potential energy and the reaction pathway as the y and x-axis, all right? And then take a look at the EA, all right? It changed from uncatalyzed to catalyzed, all right? So the energy barrier, right, so-called, is lowered by a lot. So a lot more molecules will have the required energy, therefore you have a higher rate of reaction.